All right, let's go ahead and get started. My name's Ryan Darst. I am a solution architect based in the U.S. My role in Checkpoint is I'm an evangelist for Checkpoint, and I also handle mostly management and automation things for Checkpoint. And as part of this, I'm going to show some things we can do with Ansible, Terraform, and our APIs, and how we can actually do and basically deploy environments, maintain them, and hopefully you can get something out of this. In my past experience, I did 16 years, 10 at a bank, and 6 at a hospital. And so I know where you guys are coming from, having to maintain things, work on policies, and get stuff done. So it's something I constantly think about. I constantly think about when I'm doing automation, how I can, hopefully prevent people from having to get up and do change control windows. Maybe automate some of those tasks to make them easier. So let's go ahead and get started. So everyone's probably seen Restful APIs, or you've used those. Typically we're using JSON, maybe YAML, maybe HCL for the HashiCorp if you're using Terraform. But typically we're driving most of our APIs with one of these types of languages to do this. And when we talk about orchestrators that take these things in, and when I talk about orchestrators, the guys that are doing Maestro are constantly thinking, what's this got to do with Maestro? And it doesn't have anything at all to do with Maestro. This is talking about things like Ansible or Terraform or NSO, VRO. Is anyone using these in the room? Just a few? Okay. Which one? Good. They're my favorites. So, so again, these orchestrators make it easier, at least for me, to use the APIs, do stuff that's meaningful with them, do repeatable tasks to do things. So again, as a Checkpoint evangelist, I'm supposed to know every technology that we have, or I'm supposed to be evangelist for all of them. And if you look at the different portfolio we have, it's everything from endpoint, mobile, network, cloud, everything, it's basically under the sun security-wise we offer. And what we're going to show today is integrations with Dome 9, being able to control it with Terraform. We're going to tie into ServiceNow with a new R8040 feature called Smart Tasks. And we're going to also use Smart Tasks with some Lambda functions to be able to show what we can do with that. And again, R8040 feature, and we'll go from there. So hopefully everyone's seen Hitchhiker's Guide to the Galaxy. This is Marvin. So Marvin's in our story today is going to be my assistant. He's going to be the one doing all of my DevOps and doing my building my automation for me. So we got 3 things I want to show today: infrastructure as code, the efficient automation, and continuous delivery. I wonder if you're coming back for those. So in each one of these, we're going to have a section for each one. And to kind of overview what I'm going to do as part of the build, or what actually Marvin's going to do, just think, for instance, we have this AI that we have running in Azure called Deep Thought. And Deep Thought is important to us. And what we want to do is deploy an instance in Azure that's going to talk to Deep Thought. Now, our application developers that deploy these many times don't do them in a secure manner, right? So typical, DevOps, they're just, they just shoot stuff out and that's good. But it may not be in the best approach. So we have Dome 9 that's going to protect that, and we're going to drive everything with GitHub. So everything I'm going to create, I'm going to have source files for it, and we're going to pull this stuff from GitHub to be able to do it. We're going to connect up to our Azure data center, so we're going to sync our data center objects, and then I'm actually going to create a brand new cluster based on some templates running in ESXi. So I'm going to build brand new enforcement points, and then we'll end up doing a package deployment. Again, this is a new feature in R8040 that we'll show you. So again, all of it being driven and orchestrated by either Terraform or Ansible for that. And one thing I forgot to mention is that our official Terraform support, it was actually released yesterday, so it is now finally in the Terraform repository, so you can go and use that now for R80. So let's get started. So one of the things I always kind of equate to the APIs is a set of Lego bricks, right? Each API is a task. You take those tasks, you build something bigger with it. So in this case, we have, install software package, some DOM 9 stuff. And each one individually doesn't do a whole lot, but when you put all of them together, you can actually make something bigger out of it. There's also a nice API reference guide up there that has all of the information on there. So let's start with infrastructure as code. This is the base of what we're going to talk about. And again, we have our application developers deploying things in Azure, and we're going to use Terraform for this. So taking our Terraform configuration file, we are applying it to the configuration. We're putting it in cron so that every, I think it's either 5 or 10 minutes, we're checking this so that we can see that the updates are going out. And once the timer runs, Terraform is executing, it's building my instances in Azure. And I intentionally built this so that there's no security group, just like a DevOps person probably would, because they just want to have access to it. But again, this is creating my resource groups. It's creating all the stuff I need for this instance out in Azure. So my new application server is built. It can connect now to Deep Thought. So very simple, just a cloud deployment of a Azure instance. So obviously we want to protect this. So Marvin goes out and starts doing a search for DOM 9. So we want to protect these instances in this new Azure subscription we have. We want to protect it with DOM 9. So Marvin goes out, looks at the information on the Terraform documentation, pulls up the documentation, figures out how to authenticate, figures out how to do a rule set, how to do notifications, how to basically build what we need to do to notify us if somebody did deploy an instance with no security group around it. So again, very simply, Marvin goes out, creates his Terraform configuration, and again, creates the rule set, creates notifications that are required, and then applies it. Again, we're using the same logic we did with the Azure instance, where we're actually deploying it. We're going to do that out of GitHub as well. We put that in cron, so every 5 or 10 minutes, it's going out, pulling our repository, seeing if there's any changes, and it'll apply it. Again, once I configure this, we'll see that in our DOM 9 console, once Terraform finishes its work, we'll actually see we have a new Azure subscription. It's not there. Do a refresh, and we'll have our Azure subscription ready to go, ready to enforce that traffic. Got our new rule set, and if an instance is set up without a security group, it would alert us that that's going to happen. So very easy to tie these things together. So the next thing we want to do is kind of the heart of our deployment. So Marvin goes out. He wants to look at the Ansible documentation because he heard that Ansible is now supported with Checkpoint starting in Ansible 2.9. So he goes to the network module documentation, finds Checkpoint, and then we can start looking at the information that he wants to do. So lots of different calls there, add host, add network, add rule. Lots of different components here that you can use to do that. So Marvin starts going out, decides he's going to use some Ansible roles. We're going to create Azure data centers. We're going to create our policy. And again, in our policy, it has everything for the rules, the objects, everything you would need to build this. So once Marvin has this set up, we have our task set up, we have our policy here. And again, all of this is going to be driven from GitHub. So every change that we're going to make, we're not going to do it in the GUI. We'll do it all through GitHub and that fetch that we're going to do. So again, package, threat rules, all of the layer settings, whether we want to turn on app control, URL filtering, all of those things can be set. So we're going to go and do the infrastructure build, which has all of these roles where I'm creating everything I need. First thing I'm going to do is create my Azure data center object. This is a new feature in R8040 that we have. So we create my data center here, and now you can see that when I connect it up to Azure, I can see all of my objects in Azure, and all of those things are available to me now. So very simple deployment to get that done. So the next thing I want to do is I want to deploy my cluster and my policy. So again, doing the infrastructure deployment, I have screenshots here or videos of obviously been edited a little bit for time. But again, I'm building 2 virtual machines based on templates that are running in ESX, setting the first-time wizard, doing all the stuff you typically do, set up a gateway. I'm driving all this with Ansible to be able to do this. So now I'm creating the policy, again, using Ansible. And once the policy is created, now I can go in and actually create my cluster object as well. So once the cluster comes up, I'll go ahead and push policies to it. You can see the cluster's created. I'll go out and create the push policies out to it, and then I'll push the threat policy to the gateway. Been fairly straightforward, all the same things you would typically do manually. I wish I would have done this manually to see how long it took versus using the Ansible playbooks. I should have done that. But again, now I have a cluster running. Everything should turn green. Everything's ready to go. And now I'm going to turn to the last piece of our setup is something called Smart Task. So Smart Tasks are a new feature in R8040. These allow us to do things with pre-publish, post-publish, and post-policy install. So we can actually run different scripts or webhooks depending on what we want to do. So again, just like the rest of the things, my source for all of these are in GitHub. And for each one of these, I want to execute them. So the first one I'm going to add is a pre-publish smart task. So the pre-publish smart task, what it actually does is it looks for a specific user and a specific tag that gets added to a change. And it will enforce it so that that change isn't allowed if you don't have the right, if the tag is not correct, it won't let you make changes to objects that don't have that specific tag. The next one is a Lambda. So this is a post-publish. So what this one will do is this will notify me via text message if somebody changes an object that I deem very important. Again, very simple webhook sending out to AWS and pulling an SNS feature to do that. So once this is added, when we open this up, you'll see the JSON data that we're sending to the thing. It has our phone number and the tag we want it to check to give us the notification. The last one we're doing is a policy sanity check. So this one we'll check to make sure we have access to the internet, to a specific web server. If not, it'll actually use a feature in R80 called the installation history, and it'll revert our policy back to the previous one that was a known good working configuration. So now that we have all of our smart tasks set up, in addition, this one will also notify ServiceNow as well if something was failed. So now we have everything set up, but Marvin forgot he needed to add that Azure instance to our policy. So what he's going to do, he's going to go over into GitHub, and he's going to update that particular policy and put this. So in Rule 2, we'll have a change once he goes in and makes this modification in GitHub. We'll see that, and then via cron, that update will automatically be applied to that. So, so again, Marvin goes in, finds rule number 2, finds the, I think we're putting that in the source, and then it'll automatically be applied out to the rest of the system. Again, all of this I do have available on GitHub if anyone wants to see any of this. Everything we used for this is available for you there. So again, we'll commit the change. The change will start, and we'll see it actually pull this down and apply it. Okay, we'll see Rule 2 lock. We should see the new object get added into that rule, and then we see our policy installation occurring. So, so now we have everything ready in our infrastructure as code. Everything's ready to go, and everything is set up for us. So we have our policy installed. Everything's done as far as what we need. Okay, so then if we talk about the efficient operations, this is where the smart tasks come in and gives us a lot of information and notifications. So if we look at that first use case, like I said, the data center object, I'm going to modify it. It has the web control tag. I'm going to modify it and change the color to green. And by doing that, that smart task is going to notify me that somebody made a change to this, let's say, our critical object. It could be any use case, but in our particular case, we're calling this Lambda function when we do a post publish. So once the publish occurs, we'll see another smart task actually execute, and then we'll see the Lambda function being called. Once the task completes, then we'll see that I receive a text notification based on what was changed. And it gives me a notification as well of what actually occurred. The next smart task we have is the policy installation. So again, going back and going to have Marvin go in and actually disable or delete or drop our traffic on the internet access rule. Again, this could be done by mistake, obviously. But again, I'm doing this intentionally, so we drop traffic. And what will happen is, again, remember in GitHub, we're pulling, that interval. It's going to pull, see a change has been made. We'll see the drop being changed on Rule 4. Policy installation occurs. And what happens with this post-publish smart task is it's actually recording the installation history, so it knows the UID of the rule base that it needs to use. So if it's good, it records that, and if we can't access the website, if we can't access it, what we'll have is a ServiceNow ticket will get opened, and we'll actually do the revert on the policy, so we'll go backwards. So in our simple example here, this smart task is going backwards, or it's notifying us that we went backwards in one policy revision, and put an incident in ServiceNow as well that occurred. So again, very simple API call we use to trigger that. Okay. So let's talk about continuous delivery. So this one, these two things I see the most useful. So using the CloudGuard controller, something that's been around for a couple years, I see lots of customers finally taking advantage of that and being able to make their policies dynamic, being able to put that stuff in. So again, think of our DevOps team going in and changing the IP of an Azure instance. Again, remember I have this set so it's always being polled when it gets pulled in. So after a few minutes, it'll pull this this trigger in Terraform, and Terraform will go out and update my infrastructure with the new IP, and then automatically, if everything works the way it's supposed to, which is a video, so it better, everything will be out there. So we see that we updated one element, and the CloudGuard controller then, because it polls about every 30 seconds, we'll pull that IP address in, it'll make the change, so now we see 10.02.170 just like we expected, and the gateways automatically get that. We don't have to do a policy install, we don't have to do anything special with that, so it's ready to go. So again, very simple. This has been around for a while. I see a lot of customers taking advantage of this to be able to use that. So the last feature I want to talk about, I've had customers that kind of feel like this sometimes. I have customers that had 500,000 gateways. And how do you keep those in the latest jumbo hotfix? I mean, look at this guy. He's got a little bucket. He's got this really little brush. How long do you think it takes him to paint that bridge? Right? And I've had customers tell me that sometimes patching is like painting a bridge like this. By the time you get to that end, you got to go all the way back here and start over. So we have this new feature in our 8040 called software package deployment. We can drive with the API. So again, Marvin goes in, says, hey, how do I want to look at this new feature, and I want to know if I can deploy jumbo hotfixes with this. So in the API guide finds the API that we can do this. We see in our example we want to install Jumbo Take 111, and this is a cluster, right? This is the cluster we built earlier, and with that we this works exactly the way CPUs would. It does the exact same thing you would do manually. It's going to upgrade the standby member first, and then it will reboot and make sure all the connections are synced, and then it'll do the primary member and make sure everything works correctly. So again, it's using CPUs underneath the covers to do all of this. So very simple. It's actually a really simple way to do upgrades. And the other nice thing with this is if you have, let's say, a whole number of or a large number of clusters, by default this will do 10 at a time. So you can upgrade 10 clusters at a time, and this is going to do that for you. So you don't have to manually go out and run CPUs and do some of the stuff you used to have to do, or at least I know I used to have to do to be able to do that. So again, remember where we started. We had this pile of Lego bricks, and each one of these is a specific task, is made to do one specific thing. And look what we can build, right? We can build a city. We could build a Millennium Falcon maybe. But using orchestrators to take each one of those tasks that we have, put something bigger together, and use things like GitHub to be able to do the infrastructure as code side of it. So again, the three things we covered: infrastructure as code, efficient operations, continuous delivery. And again, using things like Lambda, tying to ServiceNow, GitHub, and using our orchestrators to be able to do that. And again, that's what I had for today. I thank everyone for coming. If you want to follow me on LinkedIn, you can there. And come see me in the technology room if you have any questions about what I just showed. Thank you so much.